Hello everyone, this is Mrs. Snook with section 5.4 and we're going to do two more centers of triangles. The first one is called the centroid, and that is formed by intersecting the medians of a triangle. So first up, we need to know what a median is. So a median is a segment. It's joining a vertex to the midpoint of the opposite side. That is a median. So right here in our picture, this segment is a median. It goes from the vertex of the triangle, one of the vertices, and then it goes to the opposite side. And notice it hits at the midpoint. We know this because those segments are marked congruent. Now those three medians in a triangle, there's three of them because each vertex has a median. They intersect at a place that we call the centroid. Now centroid is a very interesting idea. It's used a lot in physics and in engineering, especially mechanical engineering. Because the centroid is where the center of mass, also called center of gravity, is located. And what that means is if you had a plate, like a dinner plate, and it was the shape of this triangle, and a P right here is the centroid, you could balance that plate on the tip of your finger at that point. So let's list our medians. Well, first off, let's start with vertex A. And the median there starts at A, goes to the midpoint on the other side, so that is E. Let's go to vertex B. Starts at B, goes to the midpoint on the other side, that lands at F. And then vertex C, and then the midpoint of that other side is D. Name the centroid. That is point P. And so we're going to have some special properties that exist for each of these medians, and we're going to list them. So if we look at the median coming from vertex A, I want to show you this length here. That distance from A to P, or that part of the median, that's going to be twice as long as the distance from P to E. So AP is going to equal 2 times P to E, which also means that you can look at it from the other way. You can say the distance PE is 1/2 the distance AP. And now let's look at another way to look at this. You could also say that since AP is twice the distance of PE, you could say that AP is 2/3 the length of AE. So the distance from A to the centroid P is 2/3 of the distance all the way across. So I'd like to think of the centroid as being 2/3 of the way from the vertex, which then means that the rest of the way, PE, is going to equal 1/3 AE. All right, so let's do some practice with this. So we have the centroid P, so right here. Here's your centroid of triangle JKL. JK measures 22. So here's 22. And KN measures 13. And OL, that's this one right here, that measures 18. We're going to find each of the missing measures. Remember that M, N, and O, those are all midpoints. So midpoint, midpoint, midpoint. That's going to help you if you keep this in mind as we go. So KM, well, the midpoint is M. KL is 22, so half of that is KM. Look at NL. N is the midpoint. So since K to N is 13, N to L is also 13. And then if you look at KL, well, halfway across is 13, all the way across is 26. JO, O is the midpoint, so that distance is also 18. And then all the way across, 18 plus 18 is 36. Okay, we can also play the same game using angle measures. So Z is the centroid. Okay, TZ is a 60. T to Z. This length right here is 60. And XZ is 28. WZ is 25. And I think I misspoke a moment ago. We're not going to do angle measures. Now we're looking at measures of the medians inside the triangle. This is where we want to keep in mind those special properties of the medians. So looking for Z to V. Z to V. Well, 1/3 of the way across is 25. So then Z to V, that's the other 2/3. So I'm going to take that 25 and I multiply that by 2 and I get 50. ZY, I'm going to play the same game here. This time I know T to Z is 60. That's the 2/3 way across. So then ZY is going to be just the 1/3 or half of that. So I take 60, divide that by 2, I get 30. ZU, same game. All right, so I think I misread, so I am just going to start over on number 2. ZV, let's go ahead and highlight that, it makes it easier. So Z to V is this one here. And so what I need to use to find that length is I need to use ZX, which is right there. So 28 is the shorter piece, so that's 1/2 the length from the Z to V. So I'm going to take that 28, I'm going to double that, and I get 56. All right, now let's look at ZY. ZY is right here. So to find that length, I need to know TZ, that's 60. And this is the shorter piece. So I'm going to take that 60 and I'm going to divide that by 2 and I get 30. Now ZU, I'm going to play the same game. ZU is the longer piece because notice that goes to the vertex. So I'm going to take my shorter piece, 25, and double that and I get 50. So now I actually know enough, I can easily find the lengths all the way across. TY is all the way across, so I'm going to do my 60 plus my 30, and I get 90. And XV is all the way across, so 28 plus 56. Let's see if you can do that with mental math. Here's what I like to do. 28 is close to 30, so I'm going to add 30 to 56, and I get 86. And then I have to subtract 2 because it's really 28 and not 30. So this gives me 84. All right, the next one I want to talk about is the orthocenter. This is our second center of a triangle. That's formed by the intersection, or we find it rather, by the intersections of the altitudes. So that's a fourth kind of segment in our triangle, altitudes. So what is an altitude? Well, it joins a vertex, again to the opposite side, just like a median, but it doesn't go to the midpoint. Instead, it goes wherever it's perpendicular. So it has to be perpendicular to that other side. And the thing about altitudes, because of that perpendicular, they're not always inside the triangle. So if I look at this one, I'm going to start here, okay? I'm going to make a perpendicular angle, and that one is an altitude inside. Now we have an obtuse triangle right here. If I start at this vertex and I come down this way, there's no way for me to be perpendicular and inside this triangle and still come from that vertex. See, none of these red ones I'm drawing in, none of them come in perpendicular. The only one that's perpendicular is that one, and we got that by extending that side of the triangle. So this would be an altitude outside. Last up, we have this triangle. That one's a right triangle, right angle. And so if I go from the vertex to the right angle, guess what? I've just matched up the leg of that triangle. So this altitude is on the leg. And I know that because it's a right triangle. All right, the orthocenter, that's our fourth center. And those three altitudes intersect at a point of concurrency, and we call that point the orthocenter, which on this diagram is point P. Now, the thing about the orthocenter is it has no practical application. We are aware that it exists, but it really has no use for us. So let's go ahead and list our altitudes. Remember, they start at the vertex and they come in perpendicular. I'm going to start at vertex A. So right here is A. I'm coming across. And you see I'm perpendicular at E. So that means AE is an altitude. Same thing at B. So line segment BF, because you're perpendicular at F. And then lastly, line segment CD, because we're perpendicular at D. Orthocenter of this point is P. All right, so that's it for today's lesson. Thank you for watching and have a great day.